Ignition.
10, 9,
Tester start.
8,
7, 6, 5, 4, 3, 2, 1, 0. Liftoff.
To your mind when you hear of exploring the cosmos? Maybe it is the NASA or the European Space Agency or even the Roscosmos of Russia. But among all these one-stop players, there is yet another institution which never fails to surprise the globe with its every new mission. We are talking about the Indian Space Research Organization, or the ISRO. Since its inception in the late 1969, ISRO has been continuously adding new feathers to its cap with its tremendous success rate. Starting from Aryabhata as the first satellite, ISRO's first mission to the moon, the Chandrayaan-1 surprised the whole globe with its discovery of water on the lunar surface. Followed by it was the grand mission to Mars, the Langrangian, which reaffirmed ISRO's dominance in the space by making it the only organization to reach the red planet in its very first attempt. With its latest mission Chandrayaan-2 or the Mission Moon 2.0 in 2019, ISRO is all set to become the first institute to land on the lunar South Pole. All these achievements, ISRO has also set a global record by launching 104 satellites in one go. There are so many other feats achieved by this great organization. Apart from its huge success rate, ISRO has also proved its engineering excellence by making these interplanetary missions the most cheapest in the history of space travels. This ISRO's target lies at the hotspot of all energy. Has a very close connection to humanity since long. There are not many cultures without the importance of the sun. As the most talked about heavenly body, it is a center of human attractions and imaginations since ages. But still, this massive source of energy remains more mysterious than it is thought to be. Not much is known about Asta, who controls the life on the blue planet. So it's quite obvious that leading space research organizations like the NASA or the ISRO will never leave a stone unturned to unravel its mysteries. Based upon this idea, India has planned one of its most ambitious missions to the Sun under the name AADITYA L1. The word Aditya derives its origin from the centuries-old Sanskrit texts of India. Aditya, which literally means the unique or the son of Aditi, is one of the 1,000 names of the sun god. With this auspicious name, the mission is planned to be launched in the early 2020. But what does the name L1 mean? Let's first look into that. If we place a smaller object like a satellite in between two massive bodies at any random point, then there is a larger probability that a smaller object would go into its own orbit around one of the massive bodies due to the gravitational pull. But not at all points. Joseph Louis Lagrange, followed by Leonhard Euler, discovered such points in the three-body systems at which the gravitational pulls of the massive bodies, the centripetal force of orbital motion, and the Coriolis acceleration all match up in a way that the small object is able to maintain a stable position relative to the larger ones. These points are called the Langrangian points. Between two cosmic bodies, there are 5 such points symbolized from L1 to L5, while the points L1, L2 and L3 are present on the line passing through the center of the two bodies. On the other hand, L4 and L5 each form an equilateral triangle with the center of the larger bodies. Out of these points, L1 and L2 are most suitable for space exploration, as these points are safe from cosmic interruptions like the eclipses. Out of these 2 points, the most preferred one in between the Earth and the Sun is L1, because here the objects are never shadowed by the Moon or the Earth. Now each of the points L1, L2 and L3 are surrounded by a periodic 3-dimensional orbit called the halo orbits, in which the exploration devices are placed. These orbits originate from the gravitational interactions between the two bodies. Point in between the Earth and the Sun is placed at 1.5 million kilometers from the Earth, which is about 1/100th distance to the Sun. Now, let's come back to the Aditya mission. The Aditya exploration device is planned to be placed at the L1 point in between the Earth and the Sun. Planned for a 5-year duration, it has a total budget of 378.53 crore Indian rupees. Initially, this mission was supposed to be placed at a lower Earth orbit with fewer research options. But now, this has been upgraded to L1 with more investigations on the list. Launch mass of about 1,500 kg will be launched with Isro's most reliable launch vehicle, PSLV XL, from the Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. In order to know the objective of this mission, let's have a look at the 244 kg payloads. There are about 7 payloads. Let's have a look on them. First payload is Visible Emission Line Coronagraph, or VELC. It can create an artificial total solar eclipse in the space by blocking the sunlight by an occulter. It has the capability of spectral imaging of corona in visible and infrared wavelengths. Its objective is to study the diagnostic parameters of solar corona and dynamics. It would study the origin of coronal mass ejections in 3 visible and 1 infrared channels. Along with that, it would also find magnetic field measurements of solar corona down to tenths of Gauss. It would determine why solar atmosphere is so hot and how changes in sun can affect the space weather and Earth's climate. It has a total weight of 170 kg and is built by the Institute of Astrophysics of India. Second is the Solar Ultraviolet Imaging Telescope. Its objective is to observe the sun between 200 to 400 nanometer wavelength range and provide a full disk image of different layers of the solar atmosphere by making use of 11 filters. Sun was never observed in this wavelength range before. It was developed by A.N. Ramaprakash and Durgesh Tripathi of Inter-University Center for Astronomy and Astrophysics, Pune. It weighs 35 kilograms. The AADITYA Solar Wind Particle Experiment. Its objective is to study the variation and properties of solar wind as well as its distribution and spectral characteristics. It was developed by the Physical Research Laboratory or PRL. Fourth is the Plasma Analyzer Package for AADITYA or PAPA. Its objective is to understand the composition of solar wind and its energy distribution. It was created by the Space Physics Laboratory (SPL) of Vikram Sarabhai Space Center. Next was the Solar Low Energy X-ray Spectrometer. It was meant to monitor X-ray flares for studying enigmatic coronal heating mechanism of solar corona. It was developed by Isro'S Satellite Center or ISAC. Followed by it is the High Energy L1 Orbiting X-ray Spectrometer. Its objective is to observe the dynamic events in solar corona and provide an estimate of the energy used to accelerate the solar energetic particles during the eruptive events. It was also developed by ISAC and Udaipur Solar Observatory or USO. The last but not the least is the magnetometer, whose use is to measure the magnitude and nature of interplanetary magnetic field. It was developed by Laboratory for Electro-Optic Systems or LEOS. With these awesome payloads on hand, ISRO will definitely unravel new mysteries of the sun. But now let's have a facts review. We wish Team ISRO a very best and leave you with a small request. Please do encourage Team ISRO by liking this video and share it as much as you can. Do subscribe to my YouTube channel with the bell icon pressed so as to get all the future notifications on the global affairs. See you in the next video.
Namaskar.